Let's take a look at the first example. So in this first example, they have told me that y is equal to this expression. So we're going to take this expression for y and go substitute it into the other equation for y, hence substitution method. So we're going to take the negative 4x plus 14, and we're going to put it where that y is. So that's going to give us 6x plus 3, but where the y is, we're going to put negative 4x plus 14 is equal to 12. We're going to distribute and solve the equation. 6x minus 12x plus 3 times 14 is 42 equals 12. Collect your like terms. So negative 6x plus 42 is equal to 12. We're going to subtract the 42 over. So 12 minus 42 is negative 30. Divide by negative 6, and x is equal to positive 5. Now that you have the first answer, we're going to go substitute it back in for x. You may go to any of the places where x is. I can substitute it right there for that x, or I can substitute it right there for that x. I think the easiest place to go is in this top equation because it says y equals, and that's what we want to solve for. So y equals negative 4, but where that blue x is, I'm going to put 5 plus 14. That gives me negative 20 plus 14, which is negative 6. Now, some teachers like this written as an ordered pair, so we'll do that. 5, negative 6, remembering that every ordered pair is x, comma, y. Now, one of the things that's great about these problems is that you can check your answers. You can go back to both of the original problems. Everywhere you see an x, you're going to put a 5. Everywhere you see a y, you're going to put a negative 6. And they should be true equations. Negative 6 equals negative 4 times 5 plus 14, and that's true. Right here, 6 times 5 plus 3 times negative 6 equals 12. It does, so it is correct. All right, let's look at example 2. In example 2, they have also told me that x is equal to that expression. So I'm going to take that expression, go to the other equation, and put it in for x. So this whole 3y plus 5 is going to go up there and substitute where the x is. So that gives me 3. But where the x is, I'll have 3y plus 5 minus 4y is equal to negative 5. Distribute and solve your equation. 9y plus 15 minus 4y is equal to negative 5. Collect your like terms. So that's 9, take away 4, 5y plus 15 is equal to negative 5. We're going to subtract 15, so we have negative 5 minus 15 to get negative 20. Divide by 5, and y is equal to negative 4. Now take that negative 4 and go substitute it in one of those y places. I could go here or here, but I think that's our best bet because we want to solve it for x. So x equals 3, but where y is, we're going to substitute negative 4. So I have negative 12 plus 5, and x equals negative 7. Once again, we can write that as an ordered pair, -7, -4. Okay, let's look at example 3. Looking at example 3, there's something that's different about this one than the previous two. If you'll notice, in the previous two examples, they have told me right from the get-go that y is all this stuff, or x is all this stuff. But in this one, they didn't quite do that. So what we have to do is for ourselves decide what expression we want to substitute in. I suggest looking through the whole problem, look at all your variables, and see which one looks the easiest to get a hold of. And I can see that this x is by itself. So he's the easiest one to get a hold of. So subtract your 3y. That tells me x equals, over here I can write that as 10 minus 3y, or I can write it as minus 3y plus 10. It just matters that you keep each sign with each term. So I'm going to say -3y, positive 10. That's what I'm going to go substitute into the other equation. It's really important that you substitute it in the other one. This is the one that I used to get what x is, so therefore I'm going to substitute it into the other equation. And so I will have 5, but where that x is, I'm going to put -3y plus 10, then minus 2y is equal to 16. And I'll have a nice equation to solve. Distribute your 5. 5 times -3 is -15y. 5 times 10 is 50. Minus 2y is equal to 16. Okay, collect your like terms. -15y and -2y is -17y plus 50 is equal to 16. Subtract your 50 over. So -17 is equal to -34. Divide -34 divided by -17 is positive 2. Now take that 2 and go substitute it. I'm going to substitute it right there for y. So x equals -3, but where the y is, I'll put my 2 plus 10. So x equals -6 plus 10, or x is equal to 4. Ordered pair, x, comma, y. Again, don't forget that you can check these answers. We can go back to the original and we can say 5 times 4 minus 2 times 2 equals, and sure enough, it does equal 16. We can say 4 plus 3 times 2 equals, and sure enough, it equals 10. Okay, let's take a look at example 4. Once again, in example 4, we have to decide for ourselves what expression we want to substitute in. So look through the problem, look at all your variables. I look here and here and here and here, and I can see that this right here, that is the easiest one to get a hold of. It's all by itself. So therefore, I'm going to add the 3x over. So y is equal to 3x plus 7. And we are going to take that and substitute it into the other expression. Again, I used this one, so therefore I must substitute it back in to the other one. So I'll come up here and I'll have 6x minus 2, but where the y is, I'm going to put in 3x plus 7 is equal to 5. Distribute. Now with that negative sign, I'm going to be so careful. In fact, I'm going to draw a red warning flag so that that negative distributes to everybody. So 6x, negative 2 times 3 is negative 6x. Negative 2 times 7 is negative 14 is equal to 5. Right here, when I collect my like terms, the x's cancel. And all I'm left with is negative 14 equals 5. Well, negative 14 does not equal 5. That is a false statement. When you get a false statement, that tells us that we have no solution. The answer is not false. Don't get confused with true and false test. But instead, because it's false, it tells me there is no solution. Okay, let's look at the last one. Last one, once again, we have to decide what variable we want to substitute into the other equation. Looking through here, we can see that this one right here looks like the easiest one to get a hold of. It's all by itself. So I have 2x minus y equals negative 1, and we're going after that y term right there. So I'm going to subtract 2x, subtract 2x. That's going to bring down negative y. Make sure you bring your face with your body. That's negative y equals, same thing over here, faces with bodies, negative 2x minus 1. The problem is, though, I'm not supposed to substitute negative y in. I'm supposed to substitute y in. So therefore, we got a little bit more to do. Divide every term by a negative so that negative divided by negative is positive. Then over here, you will also have negative divided by negative and negative divided by negative. Now, I can see this is what I'm going to substitute in for right there. This is the one that I used, so therefore I must substitute into the other. So then I will say 3x plus 2, but where that y is, I'm going to put in the expression 2x plus 1 equals 30. Have a nice equation to solve. 3x plus 4x plus 2 is equal to 30. Collect your like terms. 7x plus 2 is equal to 30. Subtract your 2 over, and I'm going to get 28 divided by 7, and x is 4. All right, let's go plug it in right here. So y is equal to 2 times 4 plus 1. 2 times 4 is 8 plus 1. So y is equal to 9. As an ordered pair, we have x, comma, y, because every ordered pair is x, comma, y. If you need more practice on solving systems of equations using the substitution method, be sure to check out my practice worksheet on this same topic. There you can watch me work more examples. You can even pause the video, try the problem on your own, and then start it back to check your answer. If this video was helpful, please like and subscribe to my channel. This allows me to continue to grow the channel so I can help build your math esteem one problem at a time. See you later.